And now let's go to see how to use this AD converter. So we will get these analog voltages to be converted to numeric form that we could shown in the display or wherever we want to process that converted value. First we have to do some initialization. So we have to configure the input pins to the mode that we want, and if we would like to use some of the input pins for our analog voltage, we have to configure those input pins with this DDAR0 register. And when the input pins has been configured, then we have to choose that which reference voltage we are using. Are we using the internal or the outside reference voltage for our AD convert? And this was done with this ADMUX register. And when the initialization is done, then we could start the conversion. And the conversion is started with the bits of this ADCSR register. And when the conversion is done, then we are reading the values from this ADC register. And with the ADCSR register, there are one bit that tells us that when the conversion is done, if we are not using the interrupt services. Here's a small example of the function that will do the AD conversion. Here is the function, it's named AD conversion, and for the input we will give the byte type variable ch, this will mean that we will give the channel that we would like to use for the conversion, the input pin that we are using for this conversion. So first what we have to do is that we have to define the all AD pins for the AD converter. In here we are using all these possible pins for the AD converter. So all C port pins will be used for AD converter, and they are not using for the digital purposes. And here is that we would define the reference voltage and choose the input channel. If you look earlier slide and if you look the data sheets, here is one bit set as 1. So this means that this will define for our reference voltage the 5 volts, which is the usage voltage for this analog voltages in our application. And here's that the OR function with this register and this variable ch. It means that basically this could be created also as a plus. So it means that the if we are using here low bits for this variable defines the wanted channel that where we would like to use the AD conversion, is that this channel number will be added for this ADMUX register value. Then it means that in here we have been defined the reference voltage, and for the lowest bit for this ADMUX we will add the channel number that we would like to use for our conversion. There's a pin mode definition and defining for this reference voltage and input channel. These commands could be also put for the setup part for the program, but in here it has those has been included for the function. If you would like to reduce the code lines in the function, you could put this to setup part for the program. It's also coming faster because you don't have to run these commands each time when you do the conversion. Okay, but next time now we have been defined the input pin mode and reference voltage, and define the input channel. What we have to do next is that we have to start the conversion and enable the AD converter. So here, if you now look this earlier slides, you could see that here is the enabling the AD converter with this highest bit here, and the next bit here means that it will start the conversion. So it means that switch on the AD converter and start the conversion. Then the conversion is started. And what to do next is that now we have to, because the conversion is started here, we have to wait until the conversion is done. And there was this ADC SRA bit which was started conversion, but it's also, if we read that bit, it tells us when the conversion is done. And here is the loop that waits until this bit shows that the conversion is done. So the program waits until here until the conversion is done. And when the conversion is done, we will read the ADC register that was containing the converted value of the analog voltage. And here it's 8-bit wide because we have defined this our function as the integer. So it means that this return value is 16 bits. So there was these two registers, low and high registers, but if we create that as a 16-bit register, then we can return to all 10 bits at the same time. These are the minimum actions that you have to do for the AD converter if you manipulate the AD converter by these registers. The other way to use the AD converter in Arduino environment is to use these library functions. So this is very easy way, but it's also very slowly way. So when you do the first trials, you could use this library functions, but if you would like to make a real working code, it might be feasible to use this register manipulation, use the AD converter directly to these registers. And in here, in this example, we first defined a variable sensor value, and here's the library function analog read. This means that it will read an analog signal from the A4 input pin. If we put here 8, A5 and so on, then it reads the value from the different input pins. And what this function will do, it will do the initialization, reading, and this kind of all the same function, all the same activities that was shown in early slides by doing that with the registers. So for the first trials you could use this, but then I propose to you to manipulate the AD converter with these registers, and for this exercises that you will return, you should use this register manipulated functionality.